Welcome to 20 Minutes with Leon, and every week our special guest. Brought to you by Bio360 Expo, this is the podcast that shines a light on the movers and shakers of the bio transition and their vision to lead us to a vibrant, sustainable, circular bio world, one where life goes on. So Vlatko, hi, welcome to 20 Minutes with Leon. Welcome, nice to have you with us for this podcast.
Oh, hi, Paul and Leon. It's a real pleasure to be here today.
Great. Leon is actually our chameleon, so that's where that title comes from. That's the connection with our mascot for Bio360 Expo. So tell me a little bit. Obviously, you have been, we like to say, beavering away at something that has been in the development now for a few years and is beginning to make its way into the I'm going to say the public eye, but obviously I mean within the sectoral public eye is beginning to gain some visibility. So. Can you just sum up briefly what it is that you're working on, that you're about to bring to the market?
Yeah, of course. So I'm the founder and CTO of Hotline Labs, and we're a New Zealand startup. I guess we can say we work in the carbon capture, utilization, and sequestration field. Mm-hmm. And so what we've developed is a technology that's able to separate clean CO2 from the combustion of virtually any type of waste biomass. And that's especially relevant for modern hydroponic greenhouse growers who, I'm not sure if you know this, but use a vast amount of CO2 in order to grow their plants economically. And so we're looking to solve that problem because they're struggling to get enough of it at a good price.
Okay. So is this, when you say, so greenhouses are a very specific application and market for the technology that you have today. When you say greenhouses, is this any kind of greenhouse that we all recognize as a greenhouse, or is it, are there particular categories of greenhouse that are suitable, that are ideal for your technology?
Yeah, so it's definitely not your backyard greenhouse where your grandma or your uncle grows tomatoes. What I'm talking, those who have traveled to Holland, would have seen those giant multi-hectare greenhouses, which typically have LED lights, where everything is incredibly optimized. Typically, they grow in hydroponics, so soilless conditions, and these are really impressive installations. Like they would typically achieve yield like 50 kilos per square meter. So I'd envisage you to consider a square meter on the floor and then 50 kilos of tomatoes in it, and then multiply it by 100,000 square meters, which is about 10 hectares of greenhouse. And this is what one of these can produce. And so the reason this is so, our technology is really relevant for them because inside these greenhouses, everything is really optimized for plant growth. So the temperature is perfect. The lighting is perfect. The fertilization is perfect because they can control it very precisely without wasting any fertilizer. By the way, they use only a fifth of open field levels for fertilization. Mm-hmm. And there's very little pests, very little weeds. So at some point, the limit to plant growth becomes the amount of CO2 that there is in the atmosphere of the greenhouse. And in fact, you can't open the windows because that kind of cancels the point of being in a greenhouse.
Right.
So already 30, 40 years ago, growers have started dosing, they say, or injecting gas CO2 inside the greenhouse to maintain the levels and keep feeding them plants. And that's responsible for about 15, 20% of the yield that I mentioned earlier. It really boils down to the CO2 that they can supply. So these are our primary customers. And you wouldn't really be able to do this outside or in your grandma's greenhouse because the limitation isn't the amount of CO2, it will be something else. Maybe it's too cold or there's not enough nitrogen, etc., etc. So we're really talking here about large-scale industrial hydroponic greenhouses like the ones you can see in Holland, but also a lot around the world. There's around Europe is the main place with them. There's about 40,000 hectares of such greenhouses in Europe, and they are our main market.
Okay. Are we talking about evenly spread across Europe, or are there areas of concentration? Of you mentioned the Netherlands.
Yep.
Outside of the Netherlands, is it relatively uniformly spread, or are there pockets?
No, there are pockets. Typically, pockets you find. I think Nantes, where the conference will be, and Brittany is a big concentration in France. There's another in the southeast. There's a whole lot in northwest Italy. There's a lot in southern Spain these days. They're starting to convert the old plastic ones, which are too low tech to use our technology, but they're slowly starting to increase in tech levels and growing in glass climatized. For them, it's not about heating like in Holland. It's more about cooling. But the problem is the same. If you open the vents, then you're canceling your cooling effect, because if you open the windows, then it's hot inside again. So you literally cancel the point of being in a greenhouse. So it's a similar problem, but different climates. But yeah, you typically find pockets in various countries of these. And the UK has a number. As well.
Okay. And so today, your CO2 is obviously one of the ingredients, if it's the right word, that growers use today. So what would be the interest for a greenhouse owner or grower today to say, well, I already have my heat, I already have my CO2. Why do I need to change that?
Yeah, good question. So typically growers at the moment, because CO2 is such an essential ingredient, they get it from only two sources. So you're wondering how the hell, surely everybody has CO2. The point here is that you need the CO2 to be clean. So it doesn't have to be pure, but it needs to be clean enough so you can safely contact it with the plants. And so you can't, for example, just take your car into the greenhouse and run it there, because all the other components from the engine will hurt the plant. And as it turns out, there's very few sources of clean CO2 like that. So one is the liquid CO2 that people put in beer and carbonated drinks, or other things these come from refineries or oil wells or gas wells, and they're cleaned up and transported as a liquid. Very expensive to get in the amount the growers need. And the other one is natural gas. So natural gas being cleaned at the well actually burns fairly cleanly, and you're able to use the flue gas more or less directly, and they will cover about 50 to 60% of a typical grower demand. So for that reason, about 70% of the industry is using natural gas for heating, because they also get the CO2 on top of it. Now, these are probably not our first target market. Our first, as they say, beachhead or start toe hold market is people who have moved away from natural gas for whatever reason. That could be because it was not available anymore in a pipeline. That could be because they were worried about energy security. That could be because they had cheap geothermal heat or industrial waste heat from a nearby sugar refinery or whatever it is. So all of what these people have in common is that they don't have a good source of CO2. So they're our primary market. And we knew that sooner or later, those growers that use natural gas will have to move away from natural gas. I honestly did not know that this would be happening so early, but as I'm sure that you have heard, but it is happening, and growers that use natural gas I feel sorry for them, because it's a really terrible situation to be in. I know that many are considering not even planting because natural gas prices have gone through the roof.
Just too high.
So this transition is inevitably going to happen, and our approach has been to develop a solution for them that is going to be applicable regardless of the heating system that they choose going forward. As long as they move from natural gas, you will have this problem. And so it's one of the reasons why in fact, lack of access to CO2 was one of the reasons why the industry has been slow to move away from natural gas, because any move from natural gas without a system like ours means also a loss of low-cost CO2, and therefore a 10% production penalty to start with. So that's obviously been quite difficult for many growers to accept or move on with. And this is what we actually intend to solve by providing access to our technology to low-cost, cheap, renewable CO2 anywhere in the world, we allow growers to move away from natural gas and secure their energy transition, basically. We like to say that the CO2 is like a little hinge that moves the big door. So this is the little key that growers need to safely move away from
right.
natural gas.
That makes sense. So it's an enabler in that sense. Otherwise,
right.
It might not be an option to move away from natural gas, but with the CO2 that Hotline Labs can generate, it becomes feasible for somebody to consider another kind of heating source.
Yep.
So what is it? So
Exactly.
tell us more. Hotline Labs, then this magic box that you have. Open the box for us a little bit. Obviously, don't give away the crown jewels. I'm sure that's something that's well protected though as a new business coming on.
Of course.
But just give us an idea of what is the Hotline Lab? What is the Hotline pellet
technology? Sure.
Yeah.
All right.
Technology.
So I'll talk a little bit in circles. I'll do concentric circles of simpler and simpler, and then towards more complex explanations. But at a very basic level, we are called Hotline Labs because we are a lab, so that part's easy. But Hotline is also the name of a patented material, which is in the form of little composite pellets, sort of agglomerated powders in the shape of sort of little balls, porous little balls. And basically, in a very simple level, it acts as a CO2 sponge. So you can run a gasifier or combustion gas through it. It can load up with CO2 and let go all of the other components that are inherent in running a fire, like I'm thinking NOxes, toxes, particulates, whatever. And then at a different moment, when you want the CO2, it's enough to blow air onto the pellets, and a bit of magical chemistry happens, and I will explain a bit more, and then releases the CO2 in a stream of air. But now the CO2 is actually never been in contact with the fire, so it's guaranteed to be clean regardless of what was in the fire. And so the reason it's called hot lime is that the core ingredient of the pellet is limestone. So as you might know, limestone is calcium carbonate, and it has the ability to release CO2 if it's heated to 900 degrees, but also absorb CO2 when it's at about 700 degrees C. And so that is the key ingredient of our sponge. It absorbs CO2 at 700, releases at 9, absorbs at 7, releases at 9. And this is why it's called, because it runs at a high temperature, this is why it's called hot lime. And it's nothing to do with chutney or sauces, which is
That's good that you clarify that point, I think.
Yeah. Right.
So this is also where the cleanliness of the CO2 comes in as well, because as you explained, the other substances within the gases are not taken in by the lime pellet. They are released differently and cleansed, and they go up the stack. Yeah,
that's right. So that's at a very simple sort of basic level to understand the process, and also conveniently, this type of process fits really well with the greenhouse because the plants themselves don't have a need for CO2 all the time. So plants only use CO2 during the daytime because there is sunlight around and they photosynthesize. So they don't actually need CO2 during the night. So it's very convenient to have a batch system. So basically, we load our hotline pellets full of CO2 during the night. And then during the day, we blow air into the pellets and release the CO2. I'd invite you perhaps to link, there's a little video explaining the system on YouTube, which maybe we can link to this, to the commentary of this podcast, and people can have a look at it because it is much easier to see it visually than for me to try to explain it in so many words.
Okay, that we'll certainly do that. That makes sense. Okay, and then so the batch process and running in the day, and then running in the night, and then the CO2 being with the air being blown, being brought into the greenhouse during the day to match the photosynthesis cycle, and in terms of what it is that what's going into the gasifier, what's the feedstock and what's the sourcing of that feedstock? What is it a particular feedstock, or is it open to? Do you have it? Can you put a mix of different feedstocks in? How does all that work?
Yeah, so we feed our hotline pellets with a syngas, but in order to run the chemistry, we need a gas that is still combustible. So we typically use a gasifier to feed the hot lime during charge. And this, we use our own gasifier that we've developed for this purpose, which is very, very simple. That's why we selected to do it. As it turns out, I'm sure we'll talk about this later, it can also make biochar. That was a happy discovery when we tried it out the first time. But anyhow, this gasifier that we designed is actually optimized for a wide variety of feedstocks. So it can take biomass up to 60% in moisture, with 60% in moisture, so it doesn't have to be particularly dry. And it's a simple updraft gasifier. So as long as the stuff can flow down a tube and sit on a pile, it's probably okay for us to run. And it's a conscious choice because we are seeking to make something that is going to be universal and useful for every single greenhouse, as we are seeking to make our machines in series, like not economies of scale, but economies of numbers. We're trying to make hundreds of the same machine, and so we're trying to make it as universal as possible for every greenhouse. So
it becomes a plug-and-play installation, kind of an idea.
Yeah, it's all set up in 20-foot containers around the 20-foot container frame, so the machines can be made in a workshop and just delivered on site. We've trialed it out with our pilot plant, and it took us a week from the moment the machine was delivered on site to it running and making CO2. So that's the whole concept. And for that also very reason, we've chosen to not provide, we are not the main heating system of the greenhouse. We are an add-on that is able to process their various wastes that are on site. So it could be definitely the grower's own green waste, which we can process. That covers about half of the need, or 40% of the need. And then other local waste. It could be forestry slash local wood chips. We've tried sawmill waste. Pretty much any kind of fibrous waste will do the job for now. And in the longer term, we're looking to expand into other more sludgy or finer cut feedstocks. But at the moment, is any fibrous waste is good.
Right. Okay. At the moment, we're more talking about solid biomass waste streams.
Yeah.
And the value of that is the 15% yield, extra yield that this additional CO2 brings to the equation in terms of production of whatever if it's tomatoes or whatever else it is that's growing in the greenhouse.
Yeah.
So it's a significant balance with a low value biomass waste and a high value contribution for the grower.
Yeah, exactly. And
interesting economics.
Exactly. And because we also create the heat from the combustion, we add another element to the value stack. In fact, the value of CO2 is really, really high. So it's immensely difficult to give an exact number on the euros per ton for a grower, because it varies from season to season, from crop to crop, etc., etc., etc. But every time we've run the numbers many times, but you end up typically somewhere between 180 to 250 euros per ton of CO2 of value to the grower directly.
Right. Okay.
And that is not insignificant. That's double the value of the heat. Obviously, once again, depending on the price of the heat, etc. But it's double the value of the heat from the same feedstock. But it's not instead of the heat; it's on top of the heat. So you're effectively sort of tripling the value out of a waste feedstock in a very simple terms.
Okay.
And so, if I may to add on that topic, we were talking about char, and it was a happy discovery when we ran our pilot plant that our gasifier was also able to produce pretty active biochar. And we realized that because we have all that gear sitting around there, and it's actually not doing all that much, a good proportion of the night, because we can load faster, and then we just have to wait. We're like, well, why don't we just make char on top of this? And so we found that we could add a char production to our units with a very, very low additional capital cost. And that gives us the ability to make char at minuscule marginal costs, like barely just the price of the feed, because all the other costs of running the machine and all the heat that's produced is used, all the CO2 that's produced is used, so that our cost of production of biochar is very, very low. And so we're looking to add that on as another element of the value stack. This is kind of what we're thinking about it. And so in a way, the CO2, our ability to extract value out of the CO2 is kind of an economic engine that we can attach other components to, the char. And I think in between the value-adding ability of the CO2 and the carbon negative ability of the biochar, we are probably going to end up, and I really believe we're going to end up with a system that has it's economically positive but carbon negative. It's sort of like a carbon cascade, if you want. That I don't know if you've come across this concept.
Yes, absolutely.
So it's an economically positive carbon cascade that just creates more value than it costs to bury carbon.
So I imagine there's a lot of interest in this.
Absolutely.
The phone's ringing.
Absolutely. Actually, I'm embarrassed to keep saying like yes, I know, I'm sorry. Yes, we are definitely doing everything we can to make as many units as we can, and this is where our series approach is helpful. We are looking to set up workshops in Europe and in New Zealand at the moment, which will be able to produce dozens of these units per year. And just for context, one of our units is expected to be around, say, 600 kilowatt thermal capacity, and serve about, say, 4 to 5 hectares of greenhouse. That's really like, and that ends up being around 4.5 tons of CO2 a day.
4.5 tons?
Yeah, it's roughly a ton a day per hectare. This is extremely variable, but it's just a guideline. So it's a large amount of work.
Right, and because it's containerized, it enables multiple containers to be run in parallel and supply a larger area if you have a larger area of hectare.
Exactly. Just multiply it's economies of numbers is our approach. It's just at the right size where you can do that.
Perfect.
A lot bigger would be hard to do in numbers, but it just so happens that the demand and technology kind of match at approximately a level that you can do in container-sized blocks, and then you can unleash the power of serial production on it.
And so I imagine that the delivery of the first commercialized series units, we can maybe hope to see some in Europe arriving in 2023.
Yes,
is that realistic?
That's what I'm really gunning for, I think is the right word.
Yeah.
So just as a bit of context, to explain why it's not totally crazy to believe that, is that we have run a pilot plant. So we have our first customer in New Zealand. He's on a beautiful lake called Lake Taupo. It's very close to that. They run a geothermal greenhouse with 12 hectares. And I'd like to thank them if they're ever listening to this. Rolf, thank you. New Zealand Gourmet Mocha is their name, and so they have trusted us, and they have hosted our pilot plant for about 1.5 years, and we've been feeding their little nursery of about 0.5 hectare with CO2, and those trials went really well. We learned a lot of things, especially how not to do things, as every good pilot will teach you. And on that basis, we've built a demo-size unit, which is currently being finished in our headquarters as we speak, and we're supposed to start it up in a couple of weeks. And with the information from that, we already started, but we are working on a design for the series, the first series of units, a batch of 10, say. And we are looking at the moment. We have some partners in New Zealand already to build them, but one of the big reasons I'm actually coming to Europe is to network and discover the European manufacturing scene and see if we can find people who would be interested to partner with us and start building these units early next year.
I see. Okay, perfect.
Hence the possibility of starting to deliver the first ones towards the end of 2023.
Right. Okay.
But obviously, it's work in progress.
Right. Okay. But that's quite a short time scale. So that's good to hear that it's something that really is ready to be deployed.
Yes. Once we have the plans, it's a matter of building and installing them. Now, given that in New Zealand, much more comfortable that we can reach the timeline because we already have our contacts and our networks. But Europe will be it'll be proportional to the speed that which we can set up partnerships and manufacturing.
Get production going here.
Yeah.
But as I understand it, once it's delivered, it's also it's quite a quick setup and plug and play to be operational. It's not the commissioning time is actually quite reduced.
Because all the units are the same, so
right.
they get a quick commission in the workshop. We tested all the sort of sub features work, and then the units just are much more simple than having to custom make every single unit, right? So the commissioning is much faster.
And then it just plugs straight into the infrastructure of the greenhouse as it is.
So most greenhouses will have a CO2 distribution system. Some don't, but it's a fairly common practice to install them. So there might be some work. We need about, say, 400 square meters of flat area and a connection to their power, water, and CO2 lines. So most greenhouses have space around them. It's that kind of industry.
Okay, so that I think we've really got a good understanding now about Hotline Labs and what you do and what you're bringing to the world of greenhouses and how you helping them to be able to defossilize their activities and also have economic gain from that at the same time. So that's really super interesting, Vlatko. Thank you for spending this time with us. Just one last thing. You're going to be coming to Nantes in February, so we're really happy to be able to host you and for you to be able to. And we'll be able to put the microphone in front of you again. And what might you be able to have? What new information in terms of the pilot test you're running might you be able to provide by the time it comes to February next year? Would there be anything additional that you think you would hope to be able to give us?
Oh yeah, I think by then we should have the machine working, and I can even bring you some samples of the biochar that we make on the side. That would be good. And definitely a sort of a video presentation at least of what the whole machine looks like when it's put together in our yard and working. So they will be the biggest achievements by then, and perhaps even maybe some CAD drawings of the first serial units. What they're gonna. Well, they will be very similar to the demo, but that's what I'm hoping to have ready.
So we'll be hosting a world first.
Yeah, definitely.
Which we're very happy to do.
It's every few months we do something for the first time, so it's a common feature for startup life.
And just I think that's what also the common feature of startup life is the origin of the idea. I haven't asked you in fact, but I'm really interested to know where how did this all come about? This concept and idea of Hotline Labs and Hotline Pellets. Where did you get this idea from? Because I believe it was your brainchild initially.
Yeah, indeed. I have been so I'm a chemical engineer by training and trade. And I grew up in the 80s, with all the environmental disasters, Chernobyl and Bhopal and whatnot. And so I got in my head very early on that I should become a chemical engineer and do technical stuff and save the world and And so I ended up doing that. I got a PhD in chemical engineering, and I worked as an institutional researcher on CO2 capture systems. And a thorough analysis of the basics of the systems led me to believe that limestone is definitely the way to go because it's plentiful, cheap, safe, can be used at high temperature, and doesn't really require, it's very robust and it doesn't use up a lot of energy to run its cycle anyway. And so I've been doing technical solutions for years and years, and I was getting increasingly frustrated because I could see that technically it's feasible, but there was no progress. I couldn't get any funding. I couldn't get anything to go. And I was actually about to abandon and become a musician because I'm actually a drummer in the other part of my life. And I accidentally went to a bioenergy conference, believe it or not, and they led us to a tour of a greenhouse, which was Gourmet Mokai, our very first customer to become later on. And we were touring, and in the bus, one of them got into the bus and said, "Oh, by the way, does anybody know how to get CO2? Because we're really desperate here. We don't have any, and it's the major ingredient for growing." And I was like, "What? What are you talking about?" And I got interested because I've been working on CO2 all along, and I was despairing because nobody wanted to pay for not emitting CO2. And here there was this person that was desperate to buy some. And so I started inquiring and realized that there's this massive untapped, unmet demand from the hydroponics industry to buy CO2. And they'll happily pay 150 euros a ton for it, like any day. And I was like, oh, okay, here we go. There's something here. And because the problem had never been technical, actually, the whole CO2 capture thing has never been a technical problem. It's always been a commercial problem. And this opportunity is a way to kind of short circuit the whole, oh, we need customers. We can't fund you because we need customers, but the customers don't want it because it doesn't exist. So that was the shortcut. And I started doing it. Actually, I had to massively change the technology because what was suitable for power plants initially isn't really suitable for greenhouse operations. So much, much smaller and very low technical. There's no like plant operators. There can't be any plant operators on site. So I had to change the technology a lot. And that's where the whole other part of Hotline came from. But I'm not going to go into too much detail, but it modified the limestone approach a lot to fit that. And then one thing led to another. I saw there was a business. I managed to convince my boss at the time to let me go, let me spin off the company. And yeah, that was 6 years ago.
And here we are today.
Here we are.
And it's really interesting talking to people like you who bring something new to the game. How often serendipity has played some role in those early days. So it was a chance encounter, in fact, but a chance
Definitely.
encounter which connected with other things for you, and from there you were able to realize this.
Yeah. I think
it's a great project.
It's important to remember that many of these things are by chance, just being at the right place at the right time.
Right.
The right person, the right place at the right time.
It's a common thread. It's a common thread that we encounter often. So that's really interesting. And I guess music's loss is the environment's gain, we can say.
Yeah, it's fine. I still get to play music, so I don't mind. It's fine.
All right, but we don't get to hear you, but we'll get to hear about Hotline Labs.
For sure. Well, thanks so much for hosting
this. Thank you, Vlatko.
And obviously organizing the event.
It's a great pleasure. Okay, thank you very much. Thank you, and we look forward to seeing you in Nantes in February.
Yes, me too. See you soon.
Okay, bye-bye now.